In this video, I'll have a quick chat to you guys about the length of a vector or the magnitude of a vector. Here we mean a different thing to dimension, so dimension would be the number of elements in our vector. Here we're talking about the actual length of the vector if we were to draw it out. The first vector that we'll look at is a nice simple vector, the vector 3, 4. Now because we've only got a 2 by 1 vector when we're talking about the dimensions, that's nice and easy to plot on a Cartesian plane. So if we think about this as our x direction and our y direction, our vector will be going across 1, 2, 3 in our x dimension and 1, 2, 3, 4 in our y dimension, and would end up somewhere up here. So we could draw this vector like that. Now if we're thinking about this vector, we could say, well, that looks like a triangle to me, like that. And we could use Pythagoras' theorem. Pythagoras' theorem, we've got, here's our 3 and our 4. Just note this isn't to scale because for some reason my 3 side looks a lot bigger than my 4 side. But when we're looking at Pythagoras' theorem, we can find the length of the hypotenuse here is h as being h equals the square root of the sum of the sides. In that case, we've got 4 squared plus 3 squared. Okay, so we can use the ideas from Pythagoras' theorem really easily on this 2 by 1 vector. Let's call this vector v. We denote We denote the magnitude of v using these lovely up and down bars. The magnitude of v equals the square root of the sum of the squares of the elements in v. So here 3 squared plus 4 squared equals the square root of 9 plus 16, which equals the square root of 25, which is a lovely one, it's just 5. Another example, we can look at a vector that is a little bit trickier. Let's have a look at the vector u equals 1, 2, 3. Now if we really wanted to, we could plot this on a 3-dimensional plot, but that's still a little bit tricky to visualize. The only thing we need to know when working out our magnitude is that it's just the same idea. The magnitude of u is equal to the square root of the sum of all of the elements squared. Or I guess the sum of the squared elements. So that's the square root of 1 squared, which is 1, plus 2 squared, which is 4, plus 3 squared, which is 9, which is the sum of the square root of 14. And I'm just going to leave it like that because the square root of 14 is a pretty ugly number, to be honest. And that's it. That's all we need to know for our magnitudes.